Hey, everybody. So this is our talk today. I wanted to present how you can use a rapid pipeline directly inside of 3ds Max to do CAD optimization and processing. And basically, when you get CAD models, you've got to do lots of prep in order to get those to be render ready and to be web ready and to do real-time rendering out of those. They're just not set up for web rendering. They're set up for generating actual products and designing things. They're not really meant as presentation models, but hey, it just makes a lot of sense to use a 3D asset that you have already and use that as the basis to make something that you can create beauty renders and create real-time assets out of. But that whole process is actually quite a bit of work sometimes. And so we built this whole tool set that lets you work directly inside the apps of your choosing to do all that prep work. And so that's what we're going to talk about today. So let's see here. A little bit about me. I'm a senior 3D technical artist here at TUG, and I've been here a couple of years. And let's say before that, I was 6 years at Wayfair, leading the 3D team there, doing rendering and real-time optimization of all kinds of e-commerce products. And before that, about 20 years in game development as an artist. And throughout, since starting at Wayfair and working at DGG, I've been a part of the GLTF standards group in the Kronos group, which is all about how to advance real-time standards and rendering standards. And that's been a great way to contribute and make assets and further the PBR material structuring that we can use for all kinds of these rendering cases. So a bit about Rapid Pipeline. It's this great tool set that's got all these tools built in for handling 3D assets from optimization and conversion, but also like when you have a CAD asset, you have to tessellate that in order to make it render ready. It's got to convert it from a parametric surface into something that's triangulated. And then you can use that triangulated mesh to assign materials and UV, and then eventually put it out to a real-time configurator or a web 3D viewer, and all that's necessary. And this whole tool set provides a lot of the options for handling that data. Another big thing is CAD assets often have a lot of hidden pieces inside of them that are necessary for manufacturing information, like screws and nuts and bolts and hidden engine parts. And you can see in the microwave in the bottom corner there, there's like interior of the parts that make the microwave run. And you don't really need those when you render the asset because you're usually not taking it apart. So we have a whole like automated routine for handling, culling out that unnecessary geometry and gosh, a whole bunch of other things for helping out with 3D models. So we can take a look at it. More recently, we've added these plugins that let you run the Rapid Pipeline directly in Max, Maya, Blender, Unreal, and Substance Painter. And what this slide is really talking about is how the engine of Rapid Pipeline runs in the background behind these tools, and that's where all the processing is happening. But you're using the 3D application as your kind of front end, as your UI for manipulating that data. And then whenever you say, hey, Rapid Pipeline, do me a process, go ahead and optimize or bake or unwrap, it sends the data out to this executable running in the background. And each tool uses its own data exchange format that's best for it. So in Max and Maya, that's FBX right now. In Blender, it's GLTF and Unreal as well. And Substance is a special case where it's basically we're directly importing into Substance where you can then start to paint and manipulate your model. So they all talk to the back end, but that's how the structure of the plugins works. And then today we're going to be talking about Rapid Pipeline and Max and talking about these various things that we can do. So hopefully we can get through all of these. It'll depend on our time and how much we cover. And I really want to cover question and answers too. So as you think of questions that you have, feel free to type them into the Zoom interface. We'll get to them as we go along. So let's see. Let's go directly into Max and we can look at that. How about that? So the Rapid Pipeline interface is basically a plugin that runs directly inside of Max, and it's a dockable thing. So I'm going to dock it here behind the command panel, so it's in the same space. And basically, we've got all of these options, these kind of actions that let you do various things to your 3D models with a set of options and a run button. And it has a process log, so it shows you what it's doing while it's doing it. So the first thing probably is we're going to go to import a 3D file. And right away, what it tells us as a warning is, hey, I need a place to store the intermediary files that are going to go to the runtime in the background and then pull those into Max. And so it's saying, hey, you haven't saved your Max file yet. So where do you want to store these intermediary files? And what's going to happen is by default, it's going to go in the folder where the plugin was installed to. And so that's, if we go out to the desktop here, it's here, this RPD temp folder, which is basically in program data, Autodesk, plugins. And this is where the actual plugin itself is installed. And we have this temp folder. So you can either say, hey, I don't really care where those intermediary files go, and it'll put them here. Or you can actually save this scene, say, hey, I want to save a scene in my scenes folder in Max. I'm just going to call it demo. I already have a file there. I'm just going to save over it. And so now when RapidPipeline does its processing and saves intermediary files, all those files are going to be in a subfolder of my scenes folder. And so that's where it's going to put all these things. And so you can manage those if you want to get those files. You don't really need to. It's just a background thing. And so I like to save my data and be in charge of where my data goes. So it's nice to have that. So let's go back to import. And what we've got here is a whole bunch of supported file formats. It's even too big to fit on the screen here, but there's basically over 70 formats that we support for import, including a bunch of CAD formats. If you compare that to, let's look at the Max import options, the stuff that ships with Autodesk's product, and look at the import formats. And they have, I think I counted this before, it's about 30 CAD formats, which is pretty cool, right? There's a lot of formats here and things that you can import, but we've been able to support over 70 different formats, which is pretty awesome. So if you can make it in a CAD program, you can probably import it into our tool. And the full support list, we go out to the desktop here and go to, let's see, our documentation. Right here in format material support, we've got a list of all the CAD formats and import and export and what's supported. And it's pretty comprehensive, which is great. And it's all really nicely documented so you can figure out right away, hey, is my format supported? So let's go back to Max and go back and import. And I'm going to pull in some files and we can take a look at how these things import. So I'm going to grab something that's fairly small and lightweight, just so it comes in fast. And we'll look some more at a more complex assets like 400 megabytes. But this takes a minute and a half to import. So I'm not going to waste your time with that import process. Let's do something really fast and easy. And so this is a door that's been in a CAD file, and it's a car door, and we have these options for import. And basically you can choose whether you're importing a CAD file, and you can choose CAD related settings that you want to choose when you import it and tessellate it. Or you can go to 3D formats, which are like when you're pulling in FBX files, you can adjust how the norm maps are done. Or when you pull in a USD file, you can control how that scene is interpreted. But we're going to look at the CAD formats because we pulled in I think it's a step file. So it's an IGS file. So the first thing we have is the resolution that it does the tessellation at. And we have 5 options, which are extra fine, medium, coarse, and extra coarse. And we have custom, which custom means you can go in here and do your own custom settings. If you don't like the defaults, you can go in and adjust in a fine detail how you want to do that conversion. So for example, you can look here and see we have this kind of chart that talks about how those settings work. And so you can get in here in a fine level of detail and control how your surface is converted from this parametric surface that's in blue into the tessellated surface, which is in red. And it's always an approximation, right? Because you're going from an infinitely curved surface to something that's physical triangles. So it's just nice to have those options. So we're going to choose just the default is fine, and that's fine. CAD sewing tolerance, I'm going to disable this and show why this is important. So this basically, if your surface is made up of a bunch of patches, this will automatically merge those patches together before it tessellates the surface. And that way you get a uniform surface. So let's just disable it by setting it to 0. And I'm going to leave everything else at the defaults and import this IGES file. And we'll see it pulls in. Oh, let's see, it's fairly small in max. So we're going to need to turn on viewport clipping because it's under a unit, I think, in size. I have my unit set to meters here. So it's pulled it in and it's tessellated it. And what this model is, it's flat on the floor. So first of all, that's something that we probably want to fix. And then it's made up of 73 different meshes here. And so this is basically in a CAD workflow. Oh God, I'm zooming out here with my mouse. In a CAD workflow, you typically have all these little, let me turn on highlighting here so you can see, all these surfaces are separate little patches that the artist used to build this surface. And so that's not that useful for me from a rendering context. I probably want to have this all be one surface. So let's re-import it, and we'll use one of those options to actually merge it automatically. And that's what the CAD sewing tolerance is all about. It basically says, hey, within under, I think this is 5 centimeters. If things are, this is basically in meters. So 0.05 is 5 centimeters. Is that right? Yeah, 0.5 is 50 centimeters. So that's 5 centimeters. So anything that's under 5 centimeters next to each other, it'll try to merge those together and make whole surfaces. And the other thing we're going to do is convert Z to Y up, which is going to cause it to stand upright how we want it to do. And so go ahead and run that. It takes the IGES file and runs it through the executable in the background and then imports it into Max. And now we have one object. And you can see here from the Scene Explorer that each time you process a file, it makes a dummy object and links the new meshes to it. So that way you can easily set up your scene. I can still see that other mesh behind it. I can select it, hide all those pieces. It's all manageable within the scene. So every time now that I do any kind of processing on a model, it's going to make another copy, hide the originals, and show me the latest one, which is pretty cool because if I want to go back and redo some kind of setting, I can always do that because I always have those models sitting in the file. It's non-destructive, which is cool. But anyway, that's what the CAD, the sewing tolerance does, is it basically pulls those pieces together and makes one unified surface. And it does it according to the materials in the scene. So if this IGES file had multiple materials on it, then it would only sew those parts together that share the same material. Some of the other functions we have here remove T-junctions. So if we pull up the help file here, let's see, let's go back here. And this is what T-junctions are, is when you have two patches that are next to each other and they share end vertices. So those are now welded together, but the resolution between the patches is different. Then sometimes you can end up with these kind of floating vertices that are attached on one side, but not attached on the other. And it can cause gaps in the surface. As you decimate the surface down, if those gaps become visible, then you get these kind of hairline, kind of busy holes in your model. And this feature will basically try to remove those by either merging this vertex together or creating a new vertex on the other surface and merging those. And so that's how that works. That's what T-junctions are all about. And then we can talk about some of the other functions. So let's look at the tessellation resolution, because I think that's pretty cool to look at. If we pull open my demo assets here, oh yeah, here. So here I pulled in the car model. So again, each time you import that 400 megabyte CAD file takes about a minute and a half, but here I've done the work in advance just to save you time and show you how this works. And these are the 5 default resolutions and what the kind of result that you get from those. So fine is the default. And if we, let's see, double click on this to select it and see the number of tries for fine is 1.6 million. That's pretty good resolution. Extra fine is 3 million. Let's see, medium, the middle here, that's 900K. And then we get to coarse, which is 600K, and extra coarse, which is about 500K. So in general, I'd say just leave it default and pull those things in. If you need the extra curvature and resolution that you get with extra fine, then by all means, go for it. It does make a more kind of heavy file to have all that extra geometry. But sometimes you need that detail, right? If you're getting in close up to various surfaces and you don't want to have any kind of chunky renders going on. In general, when you're optimizing files and getting them out for web output, you don't want to have multiple millions of triangles. You want to get down to something that's under, say, 250K triangles or so, just to make the file size manageable and to make it render fast. And you can go automatically to extra coarse, right? The lowest level of detail by default, but you do get a chunky look to it. It's going to look chunky because basically it's working on the original patches of the model, and each patch is getting basically the same kind of resolution as all the others. A thing that works better is to go ahead and optimize the highest res version and have RapidPipeline do the decimation. Then you get fine curvature for the same cost in triangles, and we can look at that too. The thing I wanted to show here as well is winding order. So by default, Max is going to show you double-sided surfaces. It's going to have, for each of these options, if I select something and look at the object properties, by default, it doesn't use backface culling. So every surface is rendered, both the inside and the outside are rendered. And most path tracers work that way as well. They'll render both sides, like V-Ray and Arnold and Redshift and these renderers, they'll render both sides of the surface because that's how a ray tracer works. But when you go out to a real-time renderer, it's typically you only want to render one side of a surface because it's much more efficient that way. And this model actually shows a particular problem. Let's see, let's choose the fine model. And let's hide all the others. Let's see, what's the hotkey for that, if I can remember. I'm just going to hide these things manually. How about that? Right, and hide those. Okay, so now I have the fine model. There it is. And it's looking fine. If I go in and select all the objects, go to Object Properties and turn on Backface Cull, now we see what the problem is. That this surface is actually, they're flipped. The CAD file, probably the person who created the CAD file, used mirror operations to generate some of these surfaces and then merge them together. And so some of these are inside out. And that's going to cause rendering problems. So let's take a look at an example here. I went ahead and made a scene where I took this model and I applied some materials to it. And it renders fine in the viewport. But when I go and turn on high quality rendering, I start to see some issues here with the physical materials where these surfaces that we knew were inside out, they're rendering and getting lighting from the opposite side of the scene as opposed to the front side of the scene. And so that's going to cause various rendering issues. If we can look at an example here, I'll pull up another example, which is here. If we look, this is the viewport render with backface culling turned on, right? And those surfaces are inverted. If you go ahead and bake this surface and try to bake an ambient occlusion map, for example, or a normal map by decimating and creating a normal map, those surfaces that were inverted are going to render incorrectly. Because basically, ambient occlusion looks at the surface and says, hey, are there other crevices here that are going to be shaded? Go ahead and shade those. But these things are inverted, so they're going to go black in the ambient occlusion bay. And so we automatically have a tool that automatically fixes this model and makes it all look correct. And here you can even see, I think this is in the Substance 3D viewer. And even there, the patches, even though they're rendered double-sided, you still get these weird shading errors across the model. So it's something you really need to fix. And thankfully, we have a tool. It's also in the import options, but you can also use, actually, after you've imported it and done your material work, we can go ahead and use this option called Fixed Winding Order. And basically what this is going to do is it's going to run on whatever's visible in the scene. I don't have to select anything. I could select individual parts and say, oh, only the winding order on those selected parts. But here, with nothing selected, it just automatically takes whatever's visible and does its processing on that. And you can see through the process log here, it's gone and saved the asset out into our folder, and it's done the processing, and then it's imported the fixed asset. And here, if we look at the Scene Explorer, it's hidden the original asset, right? So we can select that and unhide it and move it over to see them next to each other, right? So it's non-destructive, which is cool. And here it's showing us the fixed model. So if we select everything, go to Object Properties, and say cull the back faces, we can see it's automatically fixed all of those for the model. So it looks great. So that's Fixed Winding Order. It's a great tool to have. I don't have to do this all manually and fix all those individually. So let's see what else. Let's look at our stuff. We talked about tessellation resolution, what that does. Let's see, what else do we have here? Talked about tessellation, winding order. We talked about sewing tolerance on the door. We talked about Z to Y up, so that also fixed the door. Occlusion culling, that's a cool one. So let's go back to Max and check that out. So let's hide the initial file that came in that had the winding order. And this is after we fixed it, right? And now what's going to happen here is that you have a bunch of meshes inside the car that are probably never seen from the outside. And in this case, this car has glass materials and it has an interior with seats and it's got a dashboard and it's got pedals down there and all kinds of things. And that's great and that's fine. And we want to see those in the rendered model. But there are things inside, say inside the hood of the car here, that we probably don't need to see. There are just hidden surfaces in here that are just not necessary because we're never going to open that hood, or what's behind here when you move things out of the way. There's stuff inside of there that we just don't need. And what happens is that we've got an occlusion culling routine that can go ahead and remove automatically parts that are never seen. And by default, in the options here, you've got various quality levels. So you can do super fast or get a little bit more thorough, spend more time on it. And what it does is it ray traces in towards the model from the outside and tries to see which parts it can't see behind other parts. But the cool thing here is that it's aware of when you have materials that have transparency, like these glass materials. Then it knows that, hey, these don't really occlude the interior surfaces that are behind those. We still want to see those seats. So don't cull those parts. You can turn this off and say, hey, I want you to ignore the glass and I want you to cull away everything that's inside the model. And that can be useful, say, if you just want to make it a super efficient model and you don't care about glass, you could set this to say, look like tinted windows that you can't see through. And then you wouldn't have to have all that interior geometry. But we're going to try it without that first, and we're going to go ahead and run it. And did I have a part selected? I think I had one part selected. Oh yeah, I had one piece selected. So only ran on that one piece. So if I deselect and say only run, yeah, so it just made that one piece for us. So let's delete that and let's make sure I've got my stuff all visible, nothing selected. And I'm going to go ahead and run this. And now it's going to look at the whole model. all the parts, and we can look at the original resolution is 2.986 million triangles. And what it's doing is computing the triangle visibility for all the meshes. And then it's going to go ahead and skip decimation because we told it, I don't want to do any decimation. I just want to do this culling. And it finishes, it pulls it in and hides the other file that we originally had in the scene and shows us now it's at 2.895 million. So it's culled about, what was the cost before? 2.995, and this is 2.895. So it's removed 100,000 triangles that we'd never see anyway, right? Why even keep those around? So let's try that again. Let's go ahead and do this one. Let's hide that guy. And here's the one that's been culled already. Things that are behind opaque surfaces, but not behind transparent surfaces. Wait, I got rid of did I get rid of the glass? What did I do? I did something wrong there. Let's delete this and try again. Okay, including the glass. So this time I'm going to say ignore transparency. I want you to remove everything that's occluded by any other mesh, even if it has glass, right? And go ahead and run this process. And now it's going to do the same thing. It's going to export out to an FBX intermediary file. It's going to run it through the executable, run it behind where all the power lies. It's super efficient code. And it's going to compute that triangle visibility for all the surfaces. And the other thing that it does here too is that it does it per part. So you can turn off, so the way per part works is that, okay, so it's done here. It's done at 2 million instead of 2.8 million, right? It's now got down to 2 million and it's gotten rid of those surfaces inside. But you can tell it basically, I want to remove every single triangle that might be behind other triangles. And so you can get down into fine grained detail and remove a ton of triangles. But as a 3D artist, I don't really like that because it's going to leave behind miscellaneous triangles that are visible behind other surfaces or through cracks in the model. This surface here, for example, it's got some fine cracks here in the hood. And so you can see some triangles back there and not see others. So I generally like to have it remove whole parts, right? And in 3ds Max speak, we would call them elements in a mesh. I don't want it to remove individual triangles because then I end up with some floating triangles inside the model. And while being physically correct, I don't really like that as a 3D artist. I'd rather have it remove whole parts. And so that's what that option does. Yeah, so now we've gotten down to 2 million, which is great. And maybe we set this material. So let's go to the material editor here. And let's grab the material from that guy, get from selected, and there's our glass. So maybe in this particular example, I'm not going to have transparency, right? I'll turn it off and it's going to be tinted glass, right? And then it works great, right? I never see those surfaces in there. Why keep them around? And that's occlusion culling and how it works. The other thing we have too is removing small parts. So you can go in and remove individual tiny little bits in the file. So if you have a whole bunch of, say, screws and tiny little parts, you probably don't want to keep those in a render ready model because they're just inefficient, right? I just don't want to have those. So you basically choose a value in scene units, and scene units are usually for us in meters. 0.01, anything smaller than a centimeter by default would be culled. And you could set this to whatever value, say anything under 2 centimeters. Go ahead and remove it. And it automatically goes through the model and figures out all those little parts it can remove. So that's culling and how it works. We've got a couple questions already. So let's go ahead and answer those. Can we batch process multiple models in one go? Yeah, so in the DCC tools that we have, if you want, you can import multiple files into one scene and then go ahead and run a process on those, right? So you can import a file, import another file, But that's a limitation of the DCC, right? It only works on one file and a go. But RapidPipeline is all set up for batch processing. So if we go to the website, for example, let's see, where's my website? Here we are. We have this whole kind of batch processing system that's built into RapidPipeline. And so if you use the website in order to process your models, these things, you can select a whole bunch of models and run them all in a batch process. And that's super efficient, right? You can choose what action you want to have run on it, remove occluded parts from all of these pieces that I've selected, right? And it automatically runs it. So that's one way to batch process, and it's super easy to use. The other thing is that we have a an API that you can use. So you can call the API from your own system and run things in a batch basically through the REST API. We also have on premise, you can run a command line interface, that's the core system itself that runs behind the plugin is this kind of CLI. It's not a CLI when you're in the plugin because you're using the DCC as your way to operate on it. But behind all the scenes, it is this CLI that's running and it's super efficient. And it's all written around how to batch process assets. And so we have big companies that run these things in the background and run them on a tons and tons of assets, millions of assets, converting and optimizing things. And that's a great way to do it in a batch way. But really, these DCC integrations are all built around, hey, I have this one model and I need to work on it and improve it progressively and figure out which parts are broken. And it's built around that. And the DCC provides you ways to select various parts, which makes it really easy to adjust it all manually. So hopefully that helps. Let's see. Done. Does the plugin support other formats besides GLTF? Yep, it does. So I talked about how we have over 70 different formats, and those are all on the website. So you can go here and go to the documentation, and you go to reference docs, and you go to 3D processor, and you look at format and material support. And so here's where we list all GLTF features, VRM, which is a great format for avatars, USD, all the different flavors there, FBX, OBJ, PLY, STL, CTM, and then all these CAD formats and what they support. Yeah, a ton of formats. And basically, we support importing all of those formats, right? But for export, we have a more fine-grained set of files that we can export. We can't go directly back out to a CAD format, for example, because it really doesn't make sense. That's a parametric surface, and we're working on triangulated meshes, things that are ready for rendering and for web real-time export. And so it makes sense to support those formats. We have USDZ for going out to Apple devices. Usually GLTF is the great one for web and for PC devices or Windows devices, and then a bunch of other formats that make sense for various things. USD is the new up-and-comer that basically is going to replace FBX as the interchange format of choice. And so we've got pretty good integration here for USD for a lot of our customers. And that's constantly evolving as it goes along. But all of those things are supported. And what's cool is that RapidPipeline supports the full PBR material structure behind the scene. So it handles all the PBR data like metallic and roughness and normal maps, and it can bake all those and combine all those parts together and easily supports putting all those out to real time. So let's take a look here at how that handles it. Actually, that's a good kind of thing to jump into. So you select that piece and make it visible. Did I make them all visible? Yes. Okay, so I changed the material here to be a solid material, but I think this is the one that has the interior bits. So let's go back to the material and reset up that glass. Let's make sure I've got the right material. Is that the glass that's on this? Yes, it is. And this time I'm going to set the color to white. I'm going to turn on transparency. So now it is proper glass. Once again, right? And I've got all those parts inside there, but I've culled, this is the one where I've culled the invisible parts, right? And I've got it down. This is the 3 million asset. Oh, this is the one that I fixed the winding order on, but didn't do the culling on. This other one is the one that I culled all the parts that were inside the model, right? And didn't care about the glass. So that one, I don't want to do that one. Let's get rid of that one. And I want to re-optimize this guy that we fixed the culling order on, right? So all the surfaces are facing the right way, but we haven't done the occlusion culling. So let's go ahead and remove occlusion culling and not ignore the glass. I want it to use the glass that you can see through the glass and see the parts in there, and go ahead and run this on what we've got. All right, so it's doing it all. And it's doing the visibility culling and doing that, right? And once we do that, then we're going to go ahead and do some baking and decimating and make a cleaner file, something that's ready for real-time export, and show you how that works. Okay, so it went ahead and hid the previous file and gave us this new result. And we're down to 397 entities and 2.9, right? We removed 90,000 or so triangles that are just not visible, but we kept the interior. So now let's do some baking and decimation. So one thing that we've got here is, with this is all physical materials, but there's no ambient occlusion. And one thing that's really helpful in a real-time asset is to have ambient occlusion. So for example, if we go and look out here and see what is ambient occlusion and how does it work? Let's see, do I have an image here? Let's go to this documentation and see. In here, we've got baking, and where's my ambient occlusion image? Oh, you know what? It's on my hard drive. Let's do that. Let's show it here. Normals, ambient occlusion. I had an example that's more like the benefits of ambient occlusion. So here we go. Here's some images. Should explain what ambient occlusion is. Okay, here we go. Oh, it's a PSD file. Ah, let's see. Give it a preview. Nope, it won't. What's a better way to show that? It's got to be in here somewhere. It doesn't bake it on import, but it generates ambient occlusion as part of the actions. So it's going to be in the actions docs, right? Ambient occlusion. Let's do a search. Ambient occlusion. I don't think I've added the image yet. Yeah, I haven't added the image for ambient occlusion yet. So anyway, ambient occlusion is really cool because it basically improves the look of a surface by adding all the shading into the crevices. So let's generate that. So decimate and bake atlas is the action I have selected here. And basically this will take a surface and both decimate it down to the target that we want. So say if I say for this CAD model, I'm going to go to 200,000 triangles because it's a fairly detailed model. And oh, remember our previous version of this asset. If I present my slides here, and oh yeah, there it was. The core, even the extra coarse version was like 400,000 triangles, and it still looked pretty junky, pretty janky and crooked or jagged, right? Because it's just the kind of default tessellations. But if we go in and do a manual resolution to even half of that, you'll see you get a much better quality because it's working off the high resolution surface. So we're going to decimate this down from 3 million down to 200K. We're going to bake at 4K textures. We're going to bake an occlusion map. And then there's a bunch of other settings. We don't need to go through all of these, but I'm going to go ahead and just with the defaults. We got 15 minutes left, so I got to be sure of my time here, but this is pretty quick. So it goes ahead and runs this file out to the executable, does the decimation with edge collapses, and gives us an upper limit, right? That's what this is. It's an upper limit. And we've got something called deviation percentage, which basically looks at the surface and says, hey, I'm going to get under 200K, but is there even more that I can do based on a quality metric? So it's going to look at even flat surfaces or surfaces that are deviating from the original surface and how far are we allowed to deviate. And it might even go below 200K because of this percentage kind of quality level. So if it can go lower than 200K, it will. Other things we have are like size on screen target. So you can say, hey, I want it to be a certain resolution at a certain size on the screen. And that works for, say, levels of detail as you get farther away from the camera. Or if you're rendering on a certain device and you know it's going to be a certain resolution, like say an in-car display, and you want to see a 3D version of the car on the in-car display to show you things. That's where you know that, hey, at a certain size on the screen, it doesn't need enough detail, but it's a visual metric. We can preserve tiling. So if there's tiled textures in the surface, we can bake an ambient occlusion in a new Atlas UV, but preserve tiled textures behind the scenes. And the tiled textures will still be tiled and the occlusion will not. And we have some ways to handle the UVs and ways to merge the various pieces together. Okay, so it's gone ahead and done the conversion, and now we've got one mesh node with, I think, two materials on it, and it's got it at exactly 200K triangles. And it's looking pretty good. It's a heck of a lot better than the coarse version that we had before, right? It's definitely 200K. Let's go ahead and export this out to a real-time file and view it in a real-time viewer. So by default, it chooses GLTF, which is great, but I want a single file in GLTF format, and that's what GLB is. So I'm going to call this my Gusto car, and it's 200K, right? And I'm going to save it in my demo assets. And here it gives me some options. So right away, I can do some geometry compression. I don't really need any of that, but we can do that for this model if we want. We can also choose what formats to do the textures that go into the GLTF file. So by default, it's going to use JPEG unless there's alpha in the texture. So for the glass, for example, I think this is going to use transmission, so it doesn't need alpha. But if we used alpha blend, that would have to be in the alpha map. And so then it was used as PNG file. But you can choose some other options here. WebP is great because it makes really small files. So let's go ahead and choose that. It makes a small download. You can also choose a different format for the normal map, which is cool. So sometimes you want to preserve the absolute details and have no compression on the normal map. It's really up to you. And the other cool option here are KTX files. So KTX are great because these compressed fairly small, but they stay small in memory when it's loaded on the GPU. So that's a great option. I'm just going to stick with WebP, keep it at the original texture resolution. You've got some other options. Let's just go ahead and export it directly. So here it goes. It's going out to the file folder. If we go back to the demo assets and go look and see when it's done, it finished. And let's refresh the view. And there it is. So now we've got the file. Let's open up a web browser and open up Babylon, for example, which is a great web viewer, and pull in our file. And here it is. And it's got, oh, I set up the glass wrong. So there is a setting in the glass in the physical material. By default, the physical material uses, I think, let's grab the material from the glass and take a look at it. Does it use black in the material? I think it uses, yeah, so by default, what I've done is I've used one of these presets. So when you use a preset in physical material. So as I say, a new material and choose a physical material. And I choose one of these presets. They have glass in here, right? But when you use glass as a preset material, what happens is they set the base color to black for some reason. I guess that works fine for a ray tracer, but a black base color for a GLTF file turns off all transmission and makes an opaque surface. And that's because the GLTF material uses PBR rendering and they set it up as a physical behavior. So let's not do that, right? Let's replace the material that's on our glass and let's make a new one that is 100% transparent. And yeah, gray is fine. And let's assign this to our glass. So now if we go out and find our material, I think this is our glass material, right? Yeah, that's our transparent one. So let's give it the new glass that doesn't have that problem. Okay, now we can export this thing out and get the surface that we want. So let's try it again. Let's go out to GLTF. Let's try this Gusto car, and we're going to call it V2. Okay, and I'm going to say, go out to my WebPs that I like, export it, and pull it out. And it goes ahead and finds the file in our thing and saves it out to the folder that I chose, and it finished. So let's go back to our folder here, refresh the view, and here's our new file. And now our glass is transparent like it should be. Oh, wow. Look, it said it's super thick. So that's something I'm ready to just set the volume because it by default uses the volume extension for glass. So we'll need to adjust that some because it's making it look like the whole interior is one solid piece of glass. I think what I need to do is check the baking settings and not have it merge it all as one object, but make each glass a separate piece of object, which will make it render more correctly. So that's how it works. But basically, the whole system works off of being able to adjust things dynamically and adjust them in our DCC and do all this processing. And it saves each step. So I can always go back to the last step and do more stuff. So let's go back to our deck, make sure we've got all that. We went through all those options. Oh yeah, so we've got some new features in progress, which I wanted to touch on briefly, and then we'll get back to Q&A. So a couple things that we've got going on is that by default right now, GLTF, for example, is always triangulated. So our system is set up, and when you're tessellating a CAD file, usually it's all into triangles. But most artists that I know love to work in quads instead. And quads are just much easier to edit. It's easier to select loops and rings and do UVs. And if you have to do skinning and weighting to bones, then it's a lot easier to work with quads. And so we've got some initial support of converting from triangle tessellated meshes into quad support. And that's ongoing right now. And you'll see that within the next few months or so. The other thing that people have asked for is hole filling, or what's also called defeaturing, which is basically you have these screw holes in meshes that you don't really need. Sometimes they're really small features in a model. And what we can do is automatically fill those in and remove the interior surfaces. And so that gets it to be really efficient and removes all these kind of extraneous surfaces that you don't really need. And it's not axis dependent. Even if the circles are off axis and are not directly on X, Y, or Z axes, we can still remove those intelligently. So that's looking pretty exciting as well. So let's get back to Q&A here. We talked about GLTF and the other formats, right? So that's done. Somebody put in baking. Oh, good. Baking occlusion maps, right? And why that's important. So let's open that up in the web browser. We can look at that. Thanks to whoever posted that. Ah, yeah. So there's our example image, right? Which is Without ambient occlusion, you get kind of things looking over bright and not really very realistic. But with ambient occlusion, all of that kind of soft shadowing is baked into the surface and works really well in a real-time renderer. And that's very efficient. Another thing that I should mention as a part of that is in the web system, you've got what's called embeds, which you can actually run your files out and share a URL that people can view your files. And so works really great for showing off what's going on with the model, and people can view it. You just send them the URL and they can view it. But what's nice here too is that you can see what the occlusion is baked at. And with that occlusion, you get all that kind of detail, becomes much easier to view. The other thing that's cool here is that you can view these things in AR right on your phone. So if you scan this with your phone, you'll be able to look at this model and check it out on your actual device. So that's pretty cool and fun to look at. So that's occlusion. So the other question we had was, does it require exploded baking setups, or does it automatically manage ray distance protection to prevent bake artifacts, especially for AO and normal map baking? Yeah, so we don't do a ray distance lookup, but basically you don't need to explode the surfaces. You can choose to bake individual parts if you want, or you can set up different things in the baker. So let's go ahead and look at some of that. In here, in the baking, let's look at where is it? I want decimated bake atlas. And we have bake materials. So here you can choose how you want to bake the materials. If you want, you can have each material is going to bake itself independently of all the other materials. And so it'll bake a separate atlas per material. And then in that case, it's only looking at all the surfaces that comprise that material and baking that as one whole. And so, for example, the tires would render as one material, right? All those tires would be one. And the paint would be a separate material and bake on its own. So that's a way to avoid ray misses or things interpenetrating each other in the bakes. And the other thing is that we have ways to merge all the meshes together. So in the end result, after the baking's done, it'll merge all these pieces together. You can either choose, hey, I want to do no merging at all and keep all those separate pieces. So if we look back at this guy, let's hide the finished result and look back at this one. We have 397 entities, but I think something like 12 materials in the scene. So here you could say, hey, I want to merge by material and end up with 12 objects. There's a bunch of options, things in there for doing all those different things. So hopefully that answered that. How are we doing for time here? Make sure we're not going over. We got 1 minute left. Baking creates auto-generated cages, etc. Yep. It looks like those are answers to the question. So I think that's it. I think we got all our answers done and figured out. I wanted to thank you all for coming today and checking out our stuff. And hopefully that gave you a lot of information about what's going on. One thing I wanted to note here is this little icon. If you go to our website and look for this chat icon, it goes directly to a person. And we don't use actual AI agents on the website. So where's my web browser? There it is. So if you go to our actual site and click the chat button, you can talk directly to a person, which is super helpful in that we will provide accurate answers that are tailored directly to what your questions are. So that's one way to contact us. Another way is to go to the website here, and you can just contact us, get in touch and ask questions directly of our team. We're always happy to talk and provide more detail if that helps. So anyhow, I think that's it. I think that's all. Thanks so much for coming today, and we'll provide a recording of this on YouTube after we're all done. And you should see that out in a week or so. Other than that, thanks for your questions. Really appreciate it, and great to have you here. Have a great day. All right, and I think that's it. Yep, thank you, Vikram.